Hello everyone and welcome to another lesson on Google SketchUp. Yet again, we are going to learn a few skills in the Google SketchUp. This time, let me start with an example so that I can tell you what is the importance of the next thing that we are going to learn. Here is an already opened window of Google SketchUp. Let's take a small example. For instance, I'll draw supposedly say a slab. I'm going to pull this slab to say 150 mm. That is a standard thickness of the slab. And I make this a group. I select everything with a triple click, make it a group and move selected upwards to make a copy at 3000 mm, which makes it an ideal slab with the scale you can see with the human figure. This is an 3000 standard gap between two slabs. Now, when I need to connect them both, I need to make a staircase or steps or any other module that connects both the slabs. Here, if I require to have say a 4 feet, that is a 1200 mm length of the width of the slab that is required to make staircase, I won't be able to connect them both unless I make a staircase. So I will paste in place and I have the line. I'm going to push this slab up to the reference line and I can now delete the leftover. I have a gap or a difference of thickness or the width of the slab by say 1200 mm. If I now decide to make a step from the bottom of the slab and connect it to the upper level, I'm going to make, for the basic step, I'm going to make a division in the slab, the first surface. I'm going to repeat with a thread that is going to be 300 mm, that is 30 centimeters. Just after entering the 300 mm line, I'm going to write X. You can see there is X written in the bottom right side in the distance tab, and I'll multiply it with 11. And when I enter, I have this 11 divisions or the 11 threads. I'm going to have to pull each and every one of them by 15 centimeter, that is 150 mm. And when I double click the second one, it is going to grow by 150 centimeter, 3 times for the second, third, and 4 times for the fourth, and so on. The other way is you can pull it here up to the certain level you require, then type 150 and let it go. So this is a tedious procedure, right? When you see there is a lot of work to do. After this, you need to create a mid landing, say 1000 mm. And again continue the same procedure by pulling this surface by another 3000 mm, or approximately whatever is the distance that you are going to require for your dogleg staircase. In this particular instance, it is a tedious procedure. So instead, we are going to learn how to use plugins which can create these entities or such models or such small detailings whenever required. Getting back to the presentation, let's again start with the difficulty level that is required. You need to have more than the basic knowledge of Google SketchUp, operation and 3D modeling in Google SketchUp. So said is the basic of Google SketchUp that is required. The second set or the skill set that you require to have is the basic knowledge of geometry, shapes, surfaces, just like the last tutorial. And also you need to have a good understanding of surfaces and materials. Materials also define the scale of your model. Hence, it is very necessary to have a keen eye on the surfaces and the materials that you use. Let us also try to understand what are the objectives of our course. That is, the participants, you guys, will be able to implement what? The first one is, you will be learning to use the right plugins to create architectural elements. See, there are multiple fields and there are multiple plugins available for different kind of work, creative, mechanical, design related, art related, and so on. But here we are going to particularly consider only architectural elements. Also, you are going to learn how these plugins can increase the speed of your modeling. Moving to the next slide. What will you be learning in this project? It is very necessary for you to know what is the outcome for the project study that you're going to do now. I'm going to mention and use and install for you the best of architectural plugins that are available in the market. There are few which are paid, but we will cover all the freewares which are available on the website of Google. We will be showing you every link and each description. Freeware are the easiest way of reaching the tools. So we will be for now considering freewares. We are going to be describing and I am going to take you through step by step through each plugin and show you how to use it. We are also going to implement the plugins in large scale architectural models for you to understand how you can use them into blank models and bring them to life. And also, like the last session, we are also going to teach you tricks and tips and shortcuts so that you can do your work at a better pace and get more creative output in lesser of time. What are the prerequisites or the requirements that you need to have to start the projects? First one is the basics of geometry and shapes and surfaces, like we mentioned earlier. Also an intermediate level of knowledge of SketchUp. I would call it intermediate because there is more than the basic which will be required to cover this part. Understanding of architectural elements, designing scales, and so on. Who are the people or who are exactly the participants who can benefit from this course? Of course, the participants who are working in architectural designing, planning and interior designing. Those who are willing to learn architectural modeling for their livelihoods or maybe out of interest. Students of interior designing, contractors who want to describe their designs better or understand what is the geometry of the design or the scale of the model. Also the carpenters for woodwork and so on. Moving to the next slide. By the end of the project, you will have following skill sets under your belt. To start with, you will have an hands-on to the exposure with SketchUp plugins. We will be teaching you step by step, one by one, how to use the plugins and what are the popular top 10 and top rated modules that are currently used in the market and are also free, so that no one of you has a problem in downloading the paid versions, or maybe it is easier to use the free versions. Secondly, you will have practical applications of plugins in the modeling. That is, we are going to take blank models and decorate them or enhance them by editing them with plugins or adding the models, adding different kind of components via the plugins. This particular Google SketchUp project has these following contents. We will be explaining you the best architectural plugins that can be used in the SketchUp modeling, and one by one we will be teaching you how to use with bare minimum of the memory and bare minimum of your efforts to create the best detailed models. We will be giving you descriptions and step-by-step use of each plugin. We will be implementing the plugins in large-scale architecture models to give you a demo of how you can use the complete plugin set. There will also be a case study. In the case study, we are going to be detailing an existing architectural model. It will be an house, or maybe it will be a large-scale landscape model, or maybe an institution. Anything which is not detailed, so that you can detail it with your own skills that you have learned by using the plugins. This will be the scenarios, the one that follows, which will be a part of the case study. Like I just said, we will have an undetailed 3D model which will be detailed using plugins in SketchUp. We will also be making SketchUp model with textures and materials to make it render ready. Render ready in the sense of rendering it into another image, that is, use something of a use of enhancing tool which will be maybe V-Ray or something like that. So first of all, let us try to understand what exactly a SketchUp plugin or a SketchUp extension means. So like I mentioned earlier, let us try to make this staircase. So as you can see, we have these staircase 2D single flat plane lying in front of us, and as you can see to the right bottom corner there is a tab which shows me what exactly is the pull or the extent of pull that I am giving to this particular surface. Here I want it to be 150 mm, which is a standard riser, and now I have to align rest all the steps, or probably double click to auto pull, and you can see I have the steps into 3D now. Similarly, I'll bring all the other surfaces and then pull it to 150 mm each. Bring it here, pull to 150, bring it here, and again pull it to 150, which kind of is a tiring procedure, is a lengthy procedure to create a step. Just instead, let me show you another example. If you can see, you have similar kind of flat plan of a staircase lying here. What I can do here is use one of the extensions or a plugin. Let me not name it now, but for the reference, you can just understand how exactly plugin works. It is taking a little bit of time to load. If we try again, yes, here it is, loaded and ready. Now you can put in simple values here, and you can understand what exactly is the stairs going to look like. The moment I click here, I understand where exactly is the dimension that I am going to use here, going to affect the drawing. Now here you can see the flight width. I'll require a flight width of 1200 mm. The thread depth is going to be 300 mm. Usually the standards are already filled in. The height of the riser is going to be 150 mm. As you can see, the gap in between, which is D, you can see here the cursor. You can reduce it to say 10 mm, and you can also define the number of risers in both the flights. Since it is a dog-legged flight staircase, there are going to be only 2 legs or 2 flights to the staircase. You can also define here what is the height of the handrail guide that you require, and I simply click build staircase. I'm going to define the first point, and as you can see, I am aligning it with a particular line, and the staircase is ready. If I place it on the same point as the plan, you can see it is pretty much accurate. I'm going to rotate it to 180 or probably 190 then. Yes, and I'm going to align these points with a shift and a move. Since you see here, the footprints almost match to what was the requirement, and all the procedure took me barely a few seconds. So this is how a plugin works. This is what is the basic of a plugin. There are a set of commands which are already fed with the help of a software which is installed in the SketchUp extension house, and as soon as you order, it makes the entity or the complex object or the component for you. So moving ahead, let's come back and undo the changes here. Moving forward, let's try to understand where exactly is the extension warehouse and how to access it. When you go to the extensions, you can see the list of extensions or the plugins that you have already installed. If you click the windows, the drop down has the option number 7th extension warehouse and option number 8 extension manager. These are the both that we are going to look at for now. Extension warehouse As we go on, I'm going to explain you what exactly is extension warehouse and what is extension manager. So to begin with, let's go ahead with extension warehouse. When I click the extension warehouse, if you have an active internet connection, you're going to be redirected to this page. A dialog box opens up like this, and if you are logged into the SketchUp Google account, you will understand that you have huge set of plugins that are already available on the SketchUp website, and this is the warehouse of the extensions. So this is known as the extension warehouse, where you can find all sort of plugins. For example, let's enter a couple of them and try to understand. For our reference, we will be requiring mostly the architecture and interior designing, landscaping related plugins. So let's enter. Another pop-up takes you out to the browser, where you will be redirected to the extension warehouse, and here you can see the most popular ones, the most downloaded ones, or the latest one according to what is the relevance, or you can filter it, as you can see, with a relevance, with a price if it is a paid one, and then similarly other filter options. Similarly, if I try and start with this particular set and want to install a plugin, I would go to Window and go to the second option that I just mentioned, that is Extension Manager. Extension Manager pops out and it shows you the list of the plugins that you have already installed, or you can manage here. You can update them, uninstall them. On the upper home button, you can enable or disable any plugin that you have already installed. With this bottom red install button, you can install the extensions, and since it will be linked to the last folder that I downloaded my plugins into, you can see I have all these list of plugins that I have downloaded from the websites or the warehouses, and you can open any of them. You can click any of them and then click open, and it is going to install the plugin to your system in the Google SketchUp software. Moving to the next step, we are going to learn what are the steps to download and use the plugins. Basically, you have just now learned on how Extension Manager and Extension Warehouse work. In this particular step, we are going to take you through the approach of how we are going to use the plugins in the SketchUp. The first step is going to be finding the right plugin. Since we are working with the architecture and interior designing background, we need to be known to what plugins are usable and where we do not have to waste time searching the right plugins for your applications. Your applications here are meant to be only of architecture and interior designing purposes. So we have got for you a couple of plugins which we have already chosen and worked upon to teach you how to use a plugin without going around or searching much for a suitable one. The second step is going to be to learn how to download the plugin. It has a couple of ways on how you can go and download about a plugin. We are going to learn both of them. The third step is going to be installing the plugin in the extension manager. We have had a short, very small outlook towards how an extension manager works and how to install a plugin. And the final part is going to be how to be using the plugin that you have just installed. This is going to be the most extensive step, and we are going to be requiring a bit of time to reach up to this point and work on this point. So in this particular course, we would also like you to know what are the Google SketchUp architecture plugins that you are going to learn. First of all, and the foremost, or you can call it the most important one, is the 1001 bit tools, which is a freeware. Freeware is a software which is meant to be free sharing. It does not incur any cost to the user and is meant to be used freely by everyone and anyone. 1001 bit tools is one of those tools and also one of the most important architectural tools that I have come across till date. It is being used for many years now and it is one of the most favorite of mine. In the 1001 bit tools, we are going to use all the applicable tools, the architectural tools that are required for a basic plan or a basic house to be built. Secondly, we are going to use Fredo 6 tools. Let me explain what Fredo 6 tools is. An extension or a plugin basically is a set of instructions or a small software that is installed inside the SketchUp and helps you to perform a certain category of activities like making a component, making a desired object as per the orders given by the software or the plugin. In the Fredo 6 tools, a firm or a person or an entity named as Fredo 6 has developed a bridging tool or a shared library of such plugins which are very usable to the architectural background professionals. And Fredo 6 has many other plugins. One of them is round corner, which we are going to learn. The second one is going to be joint push pull, and the third a Fredo scale. These are the three main Fredo softwares that we are going to use. To use all three of them, there will be a bridge software or a bridge plugin that is going to be used, which is known as Fredo shared library. And we are going to install that first, and on that we are going to install these three plugins. The Fredo 6 library acts as the bridge between all the three plugins and makes them function smoothly and properly. So as we discussed, we are now going to learn how to install or use an extension or a plugin. So here, let us start with the Fredo 6 tools as we discussed. We are here now going to click on the extension warehouse and we will be reaching out to a page which links us to the extension where we can find our extensions. Here I am going to first type Fredo 6. You can see what kind of extensions Fredo 6 makes. So out of the list that appears, there are a few which we have already been using, and here is a lib Fredo 6, that is lib Fredo 6 extension which I was talking about and which acts as a bridge between all the Fredo tools. And also there is one more thing that I would like to discuss with you, that is, as you can see the cursor showing you listing page. So if you know, the warehouse is also created somewhere else and listed on the page of Google Warehouse. So you can see there are free extensions, there are paid extensions, and there are listing pages as well. So listing pages basically means when I try to use this particular tool, it is going to redirect me to the page and it will have an button which will take you to the site where the extension is available for download. As soon as you click this, you will be redirected to SketchUcation, which exactly needs you to first create a login. After creating a login, you will be able to download the Fredo 6 tool library, which is free to download, and most of the Fredo tools are free. But always mind that it is not going to be available for you on the extension warehouse, but on the listing page, that is SketchUcation. So after extension visit, you are going to download and you are going to install it. Here I am going to show you in my plugin setup how I am going to install one of the plugins. I'm going to move to the extension manager and I'm going to install an extension which I have already downloaded, which is Joint Push Pull version 4.4e. I'm going to open it and you can see the Joint Push Pull is now installed, and I can enable it or disable it here with just a click. The moment I apply changes, the changes are saved. Now I can close and get back. After you restart the SketchUp, you'll get all the extensions that you have not deactivated here on the pan. Before which, let me show you how we are going to download the 1001 bit tools using the extension warehouse. So after opening the extension warehouse, since this is a free tool, it will be available. You can see the 1001 bit tool freeware popping up, and you can see I've been redirected to the SketchUp extension warehouse. So if you can see in the tab of Chrome or my internet browser, I can see the 1001 bit tools be available there. I'm going to click, and here when you see, you'll understand it is directly available for download. So unlike the Fredo 6 tools, it is not going to redirect you to another website or another source of library where you can download it, but it is directly available for download in the SketchUp library, the warehouse. When you download it, you're going to get 1001 bit tools prompt in this list where you can activate the tool. So if I click the tool, it's going to activate for me this whole bunch of the extensions that I'm going to use. These are all the tools in the extensions, which are variety, and there are so many that you can almost do any kind of stuff in architectural designing. As I move through, pointing my cursor to each one of them without even clicking, as I hover above the icons, it tells me what the functionality is. Similarly, if I try to use, say, Fredo Joint Push Pull, it pops up another toolbar which also works in the similar fashion. As I hover around or pass by with my cursor pointing to each of the icons, you can see there is an instruction line which pops down. So now we can start using the SketchUp plugins. To begin with, let us start 1001 bit tools. As we have already seen how to install and start using the plugins, we will now activate it with a right click on the toolbar, which gives us a drop down of the list of all the toolbars that are available. Here we are going to need 1001 bit tools, so I'm going to tick with a click, and you can see a toolbar. When you can see on the left this dotted line, I can drag it out, make it a floating window toolbar, or I can drag it back and place it on the main toolbar, which is a fixed docket. 1001 bit tools has a variety of tools, a lot of them, but since we have limited time, we are going to use few of them which you think will be very useful for you in the 3D modeling of particularly architectural nature. To start with, let us see a very few basic tools that we can see. From the left, if we start, you can have the same pattern of hovering above the icons and getting the information. You can see there are all sort of tools like the fillet tools, the extend tools, and here are the 3D tools. This particular icon is the beginning of 3D tools, which are mostly architectural. and that is what we are going to use majorly. To start with, let us begin with a simple icon. So once I activate this tool, you will understand we have a pop-up where we get a certain number of tabs to fill in and we will have the desired result. Before which I will just begin with drawing a line. I'm going to draw it in the red axis direction, and it is going to be around, say, 1 lakh mm, a big figure, but then that is the apt example. I'm going to select it and activate this icon. So this is 1000 width divide edge option. I'm going to try again, and as you can see, there are options of dividing this particular entity. The first one, if you see, there is a auto selection of the middle option, that is fixed distance for each segment, but you can also select it on the upper and the lower options. So see how it works is, if you click the number of segments, they will be evenly distributed. Both ends will have a point, and then it will be divided equally into the number of divisions that you want. Here I am going to put, say, 20, and if I divide edge, I will get 20 parts of the same lines. I'm going to undo, start dividing again. There is another option. If you click, you will get a point right in the center of every segment that you want to divide, and in here you will get points at both the ends of the segment that you want to divide. If you select the second option, there will be a fixed distance for each segment, which is going to be a unit that you put in here. Here I am going to require, say, around 5000 mm, and this will be setting out from the middle point. That means, so when setting out from the middle point, the distance is going to be calculated from the point towards the both end. That is, there will be a 5000 mm gap, and there will be a point marked after every 5000 mm towards both the side of the point, the middle point of the line. If you select the second option, the middle point will be considered as the middle of the segment that you want to divide. That is, there will be 2500 mm at both the ends from the middle of the line, the midpoint, and so will it be divided. There will be a point at every 5000 mm after the middle point is divided right in the center. And there is a third option, that is setting out from the start point. That is, the first point of the line will be considered as the starting point, and after every 5000 mm there will be a division. That is, a 5000 mm division starting from one end to the other end. After that, we have another option, which is evenly dividing each segment. So in this case, I will just show you an example as well. If you divide it with 6000 mm and divide the edge, each and every segment here will be equal distance of 6000 mm a division. But since it is equally divided between 1 lakh, I think the even number is dividing it equally. We are going to try another way. We are going to undo. We are going to start the divide line again, and we are going to divide this into 4500 mm of segment. So if you can see, this segment is equally divided into 4500 mm each. Again, selecting the line. Therefore, now from the start point, we are going to use the second way. We are going to divide each edge by 4500 mm. Let us see. If we divide edge, we can see there is an extra edge left. So if you select, you will understand there is an extra point. If you try to erase, you will be able to erase the line which is extra. We can explore the lines. You'll have one segment each, which you can delete. You will have all the points where you can join one by other, making the number that you require, 4, 5, 8, whatever is the number that you require. We're going to make the line. and you can erase the rest by selecting them and pressing delete. So the next thing that we are going to learn is how to create an array or arrangement of a particular certain component, column, furniture, or anything that we want to be repeated. So to begin with, let us form a small component. That is, we will try and create a rectangle. So here we are going to begin with creating a component. You can see on the right bottom corner tab that there is distance given. I'm going to give it 1000 mm, comma, another 1000 mm, that is 1 meter by 1 meter. I'm going to zoom extend so that I reach the extent of the object. I'm going to select it, pull, and take it to say 3000 mm, which is a standard room height. I'm going to select it all, make it a group, and then convert it to a component. I'm going to write a column and enter with creating. Now I have an object and I want to repeat the copies of this column, and I want to make it array on either of the sides. Maybe make a group out of it so that I have a grid ready to understand and conceptualize my space. So after selecting, I'm going to click on the linear array. As the name suggests, you can create single lined row or array of the object that you are selecting. So like the previous option, there are 3 different settings in the same. The first one is, as you can read, there is a number of entity which is evenly distributed. So what here you want to do is the number of entities, that is the number of objects that you want to repeat. I want to make it 20. So this option makes sure that the entities are placed at both the ends and then the space is divided. So I'm going to build an array, and now I'm going to define a direction. This point, as you can see, there is a crosshair now appearing, a light blue color crosshair. When I bring it near to the object, it has magnetic poles attracting it towards the midpoints and the edges, the points or the vertices of the shape. Here, I'm going to detect the center, and then as you can see, there is a green line slightly visible, or I'm going to take it to the other direction, the other axis, so it is visible better. I'm going to click. The endpoint has to be somewhere else. So after selecting the object, I have to specify the start point and the end point. You can see I have an array of the 20 columns. Let's repeat again. I'm going to click one object, click on the number of entities that I require. Here I'm going to make it 10. I'm going to build an array, a start point and the end point. I'm going to press an arrow and try if I can get it into one of the directions. And I'm going to proceed in the same direction, and I'm picking the endpoints. You can see the distance now varies, and the reason is when I selected the object and clicked the build array, I started with a reference point and then I have to pick the start point, and you can see on the right there is a vector which is being counted. To either sides I go, and it will start to fade out once the extent of the column is over, and the moment I click, it's going to evenly distribute. I will delete all the rest but keep the last one. With a click on the zoom extents, I'm back to the column. Let us now move to the second option. In the second option, if you see, there is a diagram on the up that depicts what is the behavior of the column or the entity going to be. End to end, are the placements of entities when you select this option, and to the second option, you can see only the middle of every section is considered to be a point where the entity is placed. In the second option, you have fixed distances between two entities. That is, the column is going to have a fixed distance that you input here on both the sides, and then the second entity will be placed. In these options, the moment you click, you will understand how is the behavior of the entities, which is, in case in this particular scenario, a very simple option to understand. This figure or the diagram explains it all, and that is, I guess, what is the beauty of this plugin. If you click this option, it is going to be setting out from the middle of the line, and then it is going to be spaced equally. That is, whatever is the unit that you are going to give in, it is going to place components on equal side of the midpoint to the units that you have divided here. And just like the linear one, you can choose the third option, and you can set out from one end, keeping the equal gap which is defined, and go on ahead with the same gap after every entity. Now there is another option. You can evenly distribute entities where spacings should not exceed a particular unit that you are going to define. When you uncheck this distance are measured horizontally, you can even place them vertically. Entities are bottom aligned on the path. So if you define a path, they are going to be only aligned to the path. If you unclick this, it can go to the path wherever you are defining it. In this particular option, we are going to try and see how this one works. We are going to use a gap of 2000 mm either sides to build an array, and this is the linear direction which I'm going to divide. I'm going to pick the point. We're going to pick the end point. So we are going to select this tool, and you're going to place it from the middle. That is, the distance is going to be 1000 in both the ends. I'm going to build the array, select the point of the reference. I'm going to be this corner. I'm going to pick a start point, also prompting me on either of the directions. If you can see, it's the magnetic cursor which is on either of the axes. That is on the red one, the green, and the blue. X, Y, and the Z one. I'm going to define and click to start the distance. You can see here there is a small prompt showing, please pick the end point, which I'm going to pick now. And if you can see, I'm going to click and I get these equal gapped entities. Measuring it with the tape tool, I see there is an equal 1000 gap between each of them, just like we wanted. You can try out all the other options, like setting it from the starting point, where I'm going to build an array, click the corner point, then define the pick of start point. And as you can see, after the click, after the prompt, the lines are dark, which shows you the distance is being selected. And after a particular point, the line stops extending forward. And when you click, you get the array of the columns. I'm going to undo to repeat the procedure by building an array up to the end point, where I'm going to go ahead, and the distance that I covered is always distributed equally. So when you are trying to measure one point to other, be specified that you drag it only to a length that you want. Now we're going to move to our next option, that is creating a two-dimensional array that is in two directions. If you do not select a surface and click the icon, it is going to show this dialog box which reads invalid selection, and please select a group or component before running this tool, which means if you do not select a component or an entity, these tools are not going to activate themselves. So now I'm going to click this and click to the button of creating an array. The option looks very sorted and simple. And there is also a drawing diagram which shows you in a very simple way on how you can use it. So you have 4 columns here, the 4 unit fillable columns. In the column distance and the row distance, you can fill in the distance of the gap that you want. I'm going to fill in here a 2000, and the distance of the row. You can imagine a grid of the columns that you are going to make. I'm going to use 3000 units, and the number of columns and the number of rows that you require. Say I will require 5 columns and I'll require 5 rows. After clicking on build array, I'm going to take this middle point as the reference, and I'll pick a start point on the green axis, click it to the end point, and then you can see the first line persists because that is the line which is going to have the first array line, and we are going to here use the second side. And if I click on the other side, you can see there are 5 rows and columns of the entity that I wanted just created. You can make them a group, you can use them singly, delete anything that you want out of the grid, and the space is usable. Let's move to our next option, that is a circular array. I'm going to select this object, click on circular array, and you can arrange here what is the degree of circulation of each and every object. Before this, I'm going to for once decrease the size of the object that we have, since it will be easier for me to make a plane surface. Here I'm going to reduce it by 2750 mm. You can see on the right bottom I'm typing, and you can see it's created. I would also like to make it of a particular shape, which I'm doing now. Diagonally dividing. I'm going to push the surface, and I'm going to push it further down by 150 mm. This makes it look like a small step. I'm going to treat this object as my singular object, which I'm going to rotate. After clicking, you can see there's only 3 options. So the total distance along the center axis, that is the distance vertically which you have to cover, and the number of entities which are going to be equally distributed with this particular orientation of direction, and the rotation angle. Rotation angle, if you can see here, the one which is shown here as an acute angle is exactly the polar array angle. You're going to write here 15 degree. The number of entities has to be 30. We can keep it 25. And the distance that has to be covered has to be 3000, since everything is in scale now. We're going to build an array. We're going to start point on the edge, and we're going to vertical raise it and click. You see there's a rotation of just a total of 15 degrees. So if you can understand, the array has to have the complete angle of rotation. If you write 15 degree, it is going to only rotate from here to 15 degrees above you. For this, you have to keep it 360 degree so that it rotates in the complete direction. To build an array now again, and I'm going to click, and as you can see, a 360 degree has been created using the same material and rotating it in the center. I'm going to undo this again, select and go to the option, and now you can see it's so easy that you can exactly change the height. I'll make it 6000. Try again building an array. Take it to the upper direction. By clicking an arrow, you're going to fix the direction to the upwards, and you can see the distance has been increased by double, and so is the gap between each and every entity. The lesser the entities in the same distance, the more is going to be the gap between each of them. So here we end with the array tools. We are now going to proceed, which is building the walls, components, openings, and other features. So now the next plugin that we are going to learn how to make a vertical wall. I'm going to create a surface, say a rough floor plan of a house. I'm going to use an extent of 28,000 mm, 25,000 mm. It's going to be a kind of rectangular surface. Almost turns out to be square. I'm going to select this line, move it further, reducing it by another 5,000. So now if you can measure, it is anything between 20,000 and 28,000 mm. I also would like to have another protruding edge out, and I'm going to create 10,000 and a 10,000 square. Just selecting, I'm going to place it in the middle. Selecting here, I'm going to erase, and now I have it to both the sides. I'm going to now copy select with control, place it on the other side as well, erasing these lines, or I'd rather keep them. Undoing, keeping them, and I have a basic layout, or you can say a basic rough plan. Now what I got to do is create vertical walls. So I'll use the plugin. Just after the click, you can see it makes it very easy for you to understand what is it that you are going to create now. So here you can see the first option is wall alignment. You can see the wall is going to be aligned either to the left of the surface, to the center of the line or the guideline, or to the right. And you also have wall thickness in mm, and you have wall height, that is the floor height in mm. You can untick or tick build wall as a group, otherwise each and every surface of the wall is going to be separate. So here I'm going to input for the 6 inches, I'm going to put in 150, but for the thicker wall, say 230 single brick thick wall, I'm going to align it to the left, you can see, to the right. I'm going to take it to the right. I'm going to build wall as a group, and 3000 mm is going to be the height. I'm going to build the wall. As you can see, the blue crosshair tracker is active again. I'm going to click. As I come near the edge, the crosshair attracts the edge, auto detecting. After clicking, you can see as I drag it forward, whichever direction I'm taking the cursor to, the crosshair creating the wall to the right, and then I'm going to click first here, then begins the second click up to the second edge, to the third, and to rotate it to all the edges, clicking them one by one. It's so easy that it barely takes 1/10, or you can say even 1/20th of the total time that is used to be creating a wall in a similar way from the AutoCAD SketchUp drawing. Here I need it to be next edge. I'm going to stop it here, click the final one. As soon as I click, the wall is created in itself, and it's pretty clean, neat. It has all the merged edges. When you click, you can see it is also in a single group. Hence it is very easy now, you can see, to create the walls. Enough said, we are going to move to the next icon or the next option, which is creating a puncture, which is creating a wall opening. So now here, as the figure explains, the plugin is very simple, and you have a width and a height. of the opening that you require. Here I'm going to be required to put up a certain unit. 1200 mm, that is 4 feet, is what I'll require in the width, and the height is going to be 1000 mm, that is 1 meter. Now you can also here customize the setup profile, but as you can see, here is a profile that you have to set up. The moment I click here, the profile is set up. Now, instead of making the profile, let me first show you how to make a puncture. So creating here an opening of 1200 mm as we did before, and a height of 1000 mm. We are going to create an opening. As you can see, despite the walls being in group, the cursor is detecting to whichever the face am I taking it to. The blue crosshair is active and is auto detecting the surface wherever I am pointing the cursor to. You can see, I'm zooming in for a better view. So the auto detection works very well, and I'm going to place it from the bottom. The first point is already defined, so wherever I take the cursor now, it is going to keep me aligned with the bottom line of this wall. And here is the second point, the axis point. So now wherever I take my cursor, it is only going to take me along the vertical line, and the distances, whenever you take the cursor to the next side and stop, you can see the mm is shown. Here it says 864 mm. I'm going to increase it to 2000 mm. On the right bottom corner you can see I'm typing, and the moment I click, the gap is created. I'm going to retry again. Going to create a window, create opening, and when I place it on a particular line and click it again, I get both the vertical and the horizontal lines active. And when after it's sticking to one particular surface, you click it for the third time, it creates an opening just like that, which is very easy and convenient. I would also advise you, from the personal usage, I have learned one thing, that there is no guideline or height as such for the windows to be stable upon. So pressing T, I'm going to open the measure tape and create a guideline on 1000 mm that I required to be the sill. And after creating a guideline, it will be easier for me to place the window. I'm going to do it again. I'm going to create the opening, and now since I have a guide, I can click, I can come to 5000 mm. I'm going to click it for the third time. Opening is created. I'm going to keep moving. From this point, I clicked the left corner of the window, and now it is stuck to the particular line or the guide I have created. You can see on the bottom corner, and as soon as you stop, otherwise you will get the measurement, that is the distance between the two windows or the point you have just selected and the point you are going to place. If I type here 4000 and enter, it will be now stuck to the 4000 line, so the extent is going to be only 4000. I click for the third time and the window is created. So it is as easy as that. Here I am going to select this whole entity, move it, bring it down, so all the windows are now on the same level. I'm going to click on the guideline, delete it. You can see I have opening. This is the example for a window. In case you require to create an opening which is a door, you can do it similarly. Opening height has to be 0, so that the opening is right from the bottom of the floor. I'm going to create the opening. It is going to be 2200 mm. and to create the opening. And you can see from the bottom, the door height is more. I'll click the bottom line and it will drag along the surface on the bottom line. And once I click it on a particular point, it is going to keep sticking to the same point. And when I third click, the door is open, the opening is created, and which looks very neat. Hence we are done here with the part of creating openings in the 1001 bit tools. Moving on to the next thing, we are now going to learn how to create an offset. On an offset for the creation of horizontal grooves. In here, we are going to go inside the group and we are going to consider this wall where we need the grooves or maybe more. So I'm going to select one of the surfaces. You can see the dotted surface that is selected, and I'm going to create the grooves. On the creation, you will have these particular parameters depicted in the pictures. You can see here the dimension A, that is the external dimension, the external opening of the groove. The dimension are already given in the default. I have changed them. So mine are saved on 100 mm as the external dimension, 50 mm that is half of the 100 mm as B, the internal dimension, and the depth of 50 mm in the grooves, and the spacing. If you click here, you will understand the spacing is D, center to center of two grooves. This can be increased to 200 mm, and the number of grooves is going to be 25 here. Let us create grooves. We are going to click on the bottom. As soon as you click, the grooves are created. It also asks you another option of whether or not you want to soften the edge. If you say yes, it's going to soften the edge. You can see the grooves are created. Looks pretty neat. We are going to create another surface with the grooves with maybe a little changes. I've selected the surface, clicked on the grooves, and the depth, this time we are going to increase it to 100 mm, and the number here is going to be 30, and the groove spacing is going to be 150. I'm going to create a groove here, click to the bottom of the surface and yes to the softening edges. You can compare. The grooves are much closer and the shapes are little more defined than the previous one. The grooves are closer since the distance between center to center is just around 150 mm. So now a groove is created. I'm going to delete this extra line, which is the measurement line. You can see the grooves created. Now we can move to the next option, which is creating a staircase or step in different formats. We are now going to proceed to the next step of learning how to create another entity or an element. The next one is going to be a single flight staircase. When I click, I'm going to have, it takes a bit of time to load, so I keep cancelling it and reopening it. So here in the single flight options, you have 4 types shown here. Clicking each of one of them, we are going to understand the basic difference between all 4 of them. When you see the type A, you can see it is a normal simple RCC casted staircase. In the type B, you have the profile of the staircase with a singular same width across the type A. Not much of a difference, but the thickness. In the type C, you have an I channel and you have a metal staircase. In the type D, you have enclosed casing ones, which is made in the C type channels. Let us start with a type A. So the width of the step, as soon as you click this tab, you will be taken to this particular figure where you understand what is the dimension with A, B and C, D, H, etc. the initials. I need it to be 1600 mm in units. The depth of the thread is going to be C, which is also known as the thread. I want it to be 35 mm, that is 350 mm. The thickness of the slab is here given as standard. I'm going to keep it the standard. The depth of the stringer, which is denoted by F, is not given here, but the stringer depth is going to be not 250 mm. It is going to be, I'm going to keep it as standard 250 mm. I'm going to build a staircase. Let's start with this point and try. You can hence see there is some shortcoming though the staircase has been created. We'll delete this. Try making another one. We'll increase this to 300. The riser height is going to be 150, the standard one. The number of risers that I require is 3000 divided by 150, which is going to be around 20. So I'm going to build a staircase now. I'm going to click one particular point and you can see the staircase is already being aligned to the other end. To keep it dragged or aligned to this line, which it is almost doing it automatically. The moment I click, you will see there is a staircase created, and I will move it on the red axis with the shift that I press, and here I'm going to push it on the green axis. If I want to rotate it, I'll pick the point, make it 180 degree, so this thing aligns. You can see a perfect staircase is created. When you enter the group, you will see there are these guidelines of the handrails which are made in another group, the second group, in the group already. This can be used to protrude or by the use of follow me command, used to make any kind of handrail that you require. We go to the command again. We are going to make a type D now. We're going to build a staircase. Let's try again. This time from this orientation, you can see it is auto detected and you have a step already created. I'm going to drag it along the green axis, place it here, or probably rotate it like I did in the last instance. And you can see the difference between the steps or the staircase that has been created. I'm going to align it properly. And you can see it's perfectly leading you to the upper slab, starting right from the ground. You can put it inside the ground according to your requirement. You can keep it up like shown. After the single flight staircases, we will have a look on how to create dog-legged or double flight staircases. Let us begin. As you can see, we have multiple options of creating escalators, RCC staircases, steel staircases, and so on. Here I am going to start with one of the options. Building staircase type 2, that is a dog-legged staircase. A dog-legged staircase has two flights, just like the leg of a dog running in the motion. And the main advantage is it takes just half the distance of the total flight that is used by a single flight staircase. You have an option of going from left to right or right to left, as you can see, clockwise and anti-clockwise. Here I would require the left to right one. There are already standard staircase dimensions filled up here, but here, since I have used my last dimension as 1500 mm and the thread depth and the number of flights and everything edited. It is showing me the previously saved data. So as you can see, the thread depth, which is denoted by C, is the width of the stride, which is standard of 300 mm, but we have kept it 350 here. The E exactly is not denoted here, but is the number of risers in the first flight, which is going to be 10 on the first end and 10 on the other. Since we are going to divide 3000 mm by 150 mm of riser height, I'm going to click on build staircase, click a particular end, align it to the other corner, and you can see a staircase is created on the other end. I'm going to rotate it with clicking the group and pressing right R, which creates a staircase, and I have to move it to the right. Let us also have a look now at the second type. You can see entering the group, you have this line or another group which has single line handrail profile already built in. You can create with the follow me tool any type of handrail that you want and drag it along to create the desired results. Done with the dogleg staircase, let us move to the next type, which is RC dogleg staircase, which has a similar fashion of operation. We have pre-filled units, which I have changed a few of them. The gap in between, you can see the D can be reduced, which I'm going to reduce to 15 mm. I'm going to build a staircase, and you can see as I choose from one corner and drag it around the other, there is a staircase created on the other end. I'm going to move it internally by pressing shift and moving it across the red axis. Also, I'm going to rotate it to an angle of 90 degree. I have to exactly type in -90, so it rotates in the other direction. Now perfect it is. I'm going to move the staircase in the other direction to show you the differences. You can see the profile here is staggered in the RCC staircase, and similarly in this RCC staircase you can have just single profile. If you see, this is the main difference between both the staircases, nothing much otherwise. Moving to the next option, we have metal or timber staircase. As you can see, it has few more options, a couple of them more. You can see there is a difference of two type of staircases. One is the I section, one is the C section, that is rectangular section of staircase. You can use it according to whatever is suitable to your own design. We have the flight width, the thread depth, and the other options which we have filled in. The slab thickness, you can increase it to 30 mm, and the number of risers you can control from each of the sides of the flights. I'm going to build and going to use this corner this time. As you see, as I move towards dragging the crosshair on the line of placement, I can see there is a prompt of blue colored footprint of the staircase. The moment I click, the entity is created. It is slightly inside because it detects the midpoint of the wall. I'm going to drag it a little outside from both the ends, and I'm going to now replace by moving it along the wall and placing it there. It looks pretty much perfect. Similarly, you can use a steel section which has I sections. I'm going to build it as well. I'm going to detect it on this side, place it here, and the similar line you have this other staircase as well. If I place it with a shift, you can see the difference between both the staircases. This one has a I section, whereas this one has a rectangular section. This is the only difference between both the staircases. The next type is going to be a standard spiral staircase, which when you click, you will understand there are two types. If you select the type A, you can see there is no covering of gap between every entity of the steps. But in the type B, you have it all covered. This is the basic difference between both the types of staircases. One is covered and the other one isn't filled and covered between the two steps. Here you can see the standards are already filled in. You can have changes in the risers, you can have changes in the number of steps that you want, and you can untick or tick the handrail option so that you have a standard handrail, or you can use the guidelines to make your own. In this case, I'm going to keep it checked and build the staircase. To click it here, and let me mind you, it requires a bit of time to create the complex geometries. You can see it is taking a bit of time to process the information. After a few seconds, the entity will be created. We'll have to wait for it. You cannot click on anything else since it is only going to load the graphics card and make the system slower. Rather, let it operate. You can see after a bit of delay, we have a staircase right here. Perfect in shape, entities, and looks fine. So this is the circular binding step in the staircases. Moving to the next type, there is an escalator which can be used in the commercial spaces. You can see here there is a bit of condition written that the standard width of escalators are approximately 600 mm, 800 mm, 1000 mm. In our case, we are going to use 1000 mm. You can even increase it if I want to keep it at 1200 mm. The thickness of the side panel here, the B, is going to be a standard of 20, and the floor to floor height, as we have mentioned, is 3000 mm, and the floor to floor height calculated from the picked points is what we are going to keep for now. And here we create an escalator. I'm going to use this corner this time since it is the free one, and here you can see there is a dialog box that says height from the picked point is less than 1 meter. So the height entered in the dialog box is used. It is using the standard parameters. When I click OK, you can see an escalator is created. I'm going to realign it, and it looks pretty much perfect. It reaches you from the bottom of the slab. Let me rotate to show it to you properly. And if you see, an escalator is created here. Which reminds us that we are at the end of the types of staircase that can be created, which covers most of the required and the general type of staircases. Moving towards the next part, now two more options to look at, that is creating a window frame. Here you have options of rectangular frame, beveled edges frame, and rectangular frame with extruded edges. So you have all the details to be filled. We are right now going to use a standard one. So using a rectangular frame, we are going to create a window frame, and first have to make sure we are inside the group and use the frames again. We have to create the frame for this particular opening that we have. To make it easier, let me give you a suggestion. If you cover the surface and then use this prompt, it is going to be a bit easier, and then you can delete later the internal part, and you will be able to see you have a frame ready, which makes the work very easy. We are going to try it again with the next window. We are going to click on the rectangular frame. This time beveled edges. We're going to create a window. As you can see, if I click it outside, it doesn't quite operate. But when I make a rectangular surface on it, and then I try to create, it is easier for me. It auto detects, and now I can move in, and I can delete that part, and the frame is right there. You can scale it and bring it to the external surface, or you can maybe keep it as much as you want in this particular case. Similarly is the procedure of how it works with doors. Creating the door frame, we are here going to use a rectangular standard frame. But before that, let me create a rectangular surface on the door and then use the door frame plugin. As you can see, there is a door frame automatically created. And from the inside, you need to scale it further. And here the door frame is created. It is very simple as such, the procedure. Now we can proceed for the part. So now we are moving to the next part. As you can see, we did learn how to make frames for the doors, for the windows. Now here we are going to start with the next part, which is dividing a selected surface into a panel. If you see here and we click, this is all in a group. So I'm going to create with a rectangle, pressing R, a surface on the window. Let me create it on both of them in case I have to use them for the procedures ahead. Now when I select this surface and I click the option of dividing into selected panels, you can see there are multiple options. The first option is using it as a rectangular frame, which is very plain. You can see the cursor. There is not much of beveling or extruding. In the second option, you can see the rectangular frame is beveled on both the edges to make it smooth, and in the interior finishes it is usually made in the beveled manner as shown here. The third option is a rectangular frame where you can edit the options and you can have the frame depth and everything as planned. For now we are going to choose the rectangular frame. Let us set the number of rows and columns to say 5 each, and let me have the number of columns as 4 itself again. In the bevel and extrusion depth, I can increase it to 12 mm. Rest everything we will keep as it is. You can see with the initials of D, W, W3 and W2 you have all the dimensions. We are going to create it in the middle. Right now it is set for the back one, or we can keep it front since we have to create it on the front edge of the building. And here, the moment you click, you can see the surface. When you use the group, you can delete the surface inside so that it is transparent throughout, and you can have the whole panel division of the windows. You can scale it as required and scale it up to the surface which is inside 6 inches of wall. Here is how you create a panel with divisions using 1001-bit tools. Now is that we are going to create another surface which can be edited. To tell you in very short, let me just show it to you directly. When I'm selecting this surface and I'm using the next option, which is creating grills, gratings and perforated screens. The moment you click, you have these options. This is a slightly different type of entity that we are going to make. So here when you see the width The opening and the column spacings are already given in the default. You can have this in the angles, and you can edit the surface from singly perforated to the grid size to the angle and beveled surfaces. If you see and you hover above this option of set of profile, you will understand you can create a surface or maybe use a surface to create a grill with any angle that you require, and you can convert it into a perforated grill. Here if you see how to set up a profile, I'll have to first make a profile. So I'm going to make a profile here to make a rectangle and create a free form shape. Anything that you want. For me, this is going to be the shape that I wanted. And I'm going to delete all the rest and erase with the E all the rest of the surfaces. When you click here, you will see it is a single surface now, and I think it is ready to be used. Let me reduce the size to 0.25. You can see on the right corner I'm typing it down, and the moment I enter, converted into 1/4 of the total scale it was in. I'm going to bring it on up to the surface, and we have two surfaces here now, a profile that has to be created and a surface on which it has to be created. So we click the option and we can have a setup of profile. I'm going to click it here, and we are going to click the first surface, choose it, and the cursor, which has a red marking as you saw, is now gone, and it will start to detect it on the other surface, and it has created a profile already. I'm going to reduce the gappings. I'm going to undo everything, and the row spacings I'm going to reduce them to 100. Even here I'm going to make it 100, and the height of the opening and the width of the opening I'm going to edit it to 75 mm. Let us see what changes we see. I'm going to now set up the profile, choosing this surface, and the moment you scroll down and you can detect the other surface, the cursor, the square on the cursor turns blue, which indicates the surface is ready to be punctured. And the moment I click, you can see there is this puncture, or I can create a larger surface, a pretty large one. I'm going to move it out as an individual screen. I'm going to the option again. I'm going to set up a profile, click on the surface, and now the other surface that I am selected is ready, and the screen is ready also. So you understand what kind of application this one has in creating a screen in the interior or grill in the exterior of a building. I'm going to delete this for now. So now we will move to the next option in the bit tools, that is the lure option. This option lets you create in both the directions, the vertical and the horizontal ones, panel of lures, a series of lures that you can use for windows or any other surface you want. So for an easy application, let me show you. You just have to click the option and you get the depth of the lure thickness. I'm going to decrease it to 25 mm. The spacing has to be 75. I'm going to make it little closer. And then the lure angle, that is in its best form, 30, which I'm going to type. And I want it to be in the front. So when I say create lures and I click, the surface automatically is detected by the cursor. When I bring it out, you can see it is blank, but when I take it and hover it above a plain surface, it activates to blue. And as it is activated with the blue, I'm going to click, and you can see very well the lures have been created. and they are in exact alignment of the dimensions that we just have did as an input. And you can see the whole surface is now not existing, but the lures have been created. So I will tell you a trick about how to go about it, since you do not want to reduce this surface, which you might have to use later. So I'm going to copy it with a Control C, come out of the surface in the group and exit the group, and then I'm going to press edit. I'm going to paste in place, and now despite I have a group, I also have another surface on top of this particular vertical surface, and I'm going to now use the second option, that is vertical lure, in the selected face. For the selected face, I'm going to click, and again here I'm going to change dimensions that are given initially. I'm going to increase it to 40 mm, and the spacing between the lures I will reduce it to 50, and the depth can be say 200 this time, and the angle is preset on 30. We are going to create lures, and if I do it on this activated surface, you can see it's very dense. So the part after a particular angle shows black, since there is a lot of density of surfaces, since the profiles are active. In the view, you can in the edge style edit, and you can uncheck the profiles, and you will see the model graphically looks a little lighter, a little less darker. Now you have to discuss the advantage of how this lure exactly worked in your favor. You can see when I move it out, you do not have the wall disturbed. So if you can see, if I have to click, I do have that surface remaining as well as the lures made. When in on this side, if I delete, I see there is no wall surface. So only this trick for you to understand how a surface is being turned into a lure, and that you do not need to do it on the walls if you have to use them later on. I hope this part is clear. Let's move to the next one. The next option is how to create a rectangular grill from a selected edge. So if you see, you have to create an edge. Let us go to this staircase part, and let's take one of the lines in the group, which is also an edge, and you need to make it a rectangular grill. So the moment you press, you will have this option after selection of the line, which can let you edit what is the width of the rectangular section, which I'm going to make 75 for now, and the height of the rectangular section required, which I will be making 125. And after clicking OK, you will see there is a surface already generated, and you have a geometry of a rectangular pipe which is created on this whole surface. You can click the rest of them and do the same thing, press OK, but you can see the geometry is disturbed, as it is always advisable to click only one surface or an edge at a time and make it. It will be easier if in case we consider this example of two edges. In fact, you can select the third one as well, the three edges, and use this command to create a rectangular section. And you can see a uniform section is laid with an even corner in a different group, and you can see you have this whole rectangular section created, and you can create it on as many levels and edges you want. Always remember, it is only the edge that you have to select. To the next option, which is kind of very similar, we are going to see it nevertheless. Let me select an edge for you. These are two of them, and the same option with a bit of difference, that is, it creates a circular tube and not a rectangular section. So you can decrease or increase the tube diameter, which I here want to be 150 mm. I'm going to select OK, press enter on my keyboard, and you can see there is a surface now created which is circular and a little different kind of geometry, but yes, is bonded together. So you don't have to create the edges or go around doing anything after you have created these pipes, but directly use them in the model. So we have a final few set of commands left in the plugin, and the ones that we are going to look at now are the ones that are used usually to edit the roof or make a new roofing system. To make it more simple, let me select the surface and copy select with pressing Ctrl and moving it. I'm going to bring the surface up. You can see it is already in a group. So in case you want to create a roofing system above the walls that you have already created in a house or a building, you can make this as a component. You can have it as roofing. I click to create, and now I'm going to copy this same a little further away from the model, and when whatever change I make here is going to be visible on the other end above the building, and you can simultaneously edit everything and see it happening right above the surface of the slab. So now when I go to the surface, and this option that is used to create the rafters or joists which act as the surfaces where the roofing tiles or the tiles that are used to cover the surfaces is used or mounted or screwed. So rafter width is 50 mm, which is given here as a default. The rafter depth is given as 150. We are not going to touch it for now, and these rafters can be created on a particular surface. After clicking, I'm going to click one of the surfaces and click from one point to the other, and you can see you can have these rafters, before which you can also understand how a purlin is made. So for creating the rafters, let me again come back, start creating one. You can see what is the rafter spacing. The rafter spacing can be reduced a bit to 500, and I'm going to create a rafter, say the smaller surface this time. I'm going to decide the direction and click, and you can have the rafters placed already. Similarly, I'm going to use the command on the other surface, and I'm going to create the rafter this time on another direction, and you can see the rafters have been created. Also in the other component, third part, we can also cover it up. We are going to create rafters. Surface is selected, so no blue prompt on the cursor. Here we are going to decide the direction, and you can see the girders are now placed. This looks very neat. So now I'm going to add or use another option, before which you should also know how to first create hip roof and then come to making the purlins and rafters and the other member of the roofing surface. When I click here, it's very simple to operate. The roof overhang, that is a roof that comes out, I'm going to make it 1500, and the roof pitch is going to be 30, which is also the basic and default one. Here I'm going to create, but it says you have to first select a surface. So I'm going to create this surface. I control select the other one and control select the third part, and now I'm going to create a roof with the previous, all the previous dimensions that I have given. I'm going to create, and you can see it's so easy. Directly comes in as covering, and covers the whole part with 1500 mm of overhanging part already here. Now as you have created, you might not just want to have the primary girders but also to have the other members which lift the roof up and make up to the whole roofing system. That is where the third part comes in, which is automatically creating a ridge rafter and battens or purlins. So to create it in a particular section, you need to first select the 4 adjoining surfaces which are to be connected by the roofing members, and then you come to click and you have all the details of the width of the rafters, the spacing between the rafter, which is already basically given here, which I'm going to reduce to 500 mm. And you can also add purlins. That is, if you don't add them, you do not have the vertical to horizontal division, but if you have it, you have the complete roofing system when it is required in your design. So we are going to, for now, not keep the purlins, and we are going to create. Takes a bit of time, but you can see the whole part is done. You can undo this and create another surface. So clicking again, you can see the surface. I have to go select it from the closer quarter end, and it is all created in 4 parts, which is as good as constructing a real one on the site. You got to have to delete everything separately. This is how it works. In case you also need to create a surface on the roof which is connected. Here, as you saw, we had a division in the surface. Here you can see the blue line, as well as here on the other flank is also separated from the group. We can try making a roof on this surface with the command, and we create a hip roof, and you can see the roofs are now not separate but covering the whole plane, and are, unlike the previous ones, in separate sections. These one are joined now. These are very small logical understandings that you have to. I hope all the options are clear, and this was the last of the 1001 bit tools. So the next thing that we are going to use here is a Fredo 6 joint push pull tool. I'm going to activate it with right click on the toolbar and clicking on the push pull menu. You see there is a small widget that appears, and we are not going to use all of them majorly since it is not a complex geometry that we are dealing with. But simplifying our work, we'll have 2 or 3 major options that we are going to look at for now. Here I have a few different objects or components in the picture. They're placed in the model right around the axis. To start with, you know that SketchUp doesn't allow you to push or pull multiple surfaces at once, or also the curved surfaces. It is not allowed in SketchUp push or pull in a proportionate manner the curved surfaces. This is where this plugin comes in to the play, and I'm going to give you an example. If I press the P, the regular pull or push button in SketchUp, and I try to push or pull, there is only one surface that emerges at a time, and there is no way I can select multiple surfaces and then pull them up, because it disappears, the selection doesn't come out. Basically, this has never been a tool in SketchUp to pull and push multiple surfaces at once. So this tool of a joint push pull comes in very handy. I'm going to select multiple surfaces now from multiple angles and edges, a few more, and you can use the joint push pull to thicken the surface, or a joint push pull of equal manner, that is going to pull in everything in equal proportion. You can type in on the right bottom corner, you can type in what units do you want to pull up to, and I'm typing 1000. You can see the geometry has been generated the moment I pressed enter. Similarly, on a surface like this, where you have multiple surfaces to be offsetted at once, you can jointly pull them up. I'm going to first deselect the previous surfaces. Since you can see it was also being pulled, I have selected a few surfaces on different angles, and I'm going to now use the option of joint push pull. You can see after pulling, the proportion is increasing as far as you go, and you drag out the surface from the main surface, the proportion of the plane goes on increasing. Whereas in the simple push and pull, you can just keep pulling the surface and it will exactly be pulled in the same dimension as the first one. So here I'm going to type 150, say 200, and enter. You can see all the surfaces pulled only up to 200 mm. Another good thing about pushing or pulling via this tool is that you get a smoothened up corner that you don't have to work again. And doing this, I can also tell you that using different surfaces at once we pulled by joint push or pull, you can type whatever unit is that you want to create, and you can use the joint push pull option, and in the finishing you can either click to raise the original surface. So if I click and I pull out the surfaces that I want, in the joint push pull, I'm going to type 400. I'm going to enter. You can see the offset has come out. So I'm going to use the face selection face by face, or with the connected surfaces. You see everything, all the surfaces are being pulled out. Let's come to a curved surface. With a joint push pull, you can pull out all the surface. You can keep the finishing, keeping the original face, and now you can see you have the original face already. If I type 300, I get the unit 300 in the offset. Let's see how the second option works. If you need a couple of surfaces to be pulled out but with rounded edges, you can use round push pull, where you can see you have different finishings. One with creating a new surface, keeping the original surface. The other one is creating the segment. In the hidden geometry, you will be able to see the more sections you have, the smoother is the curve. The sections you have, the curve is more into linear form. So let us try with 16, which is max. You can increase anything between 2 to 16. The moment you click, you will understand. Now here We will try to pull everything out. You can see all the surfaces that are connected are being pulled out in a rounded format. To write 200 mm and enter, you can see the whole surface is rounded up, which is very convenient to be used in SketchUp. Similarly, you saw thickness of the pipe also came out, and you can see the face is right now in grids. Let me also show you how to edit what surface you are pulling out and how does it come out. In the joint push pull, you can keep the borders on contour. If I pull it out by say 250 mm, you'll see it comes out smooth. So thickening surface is even easier with a joint push pull. Similarly, we have vector push and pull, we have normal push and pull, as well as extruding and follow push and pull. You can use these as you go on discovering what kind of commands they take up and what kind of results are out. You can also visit website which has Fredo 6 tools on them. So the next tool that we are going to look at is a Fredo 6 scale tool. Let me first start explaining by making an entity. It's going to be 1500, comma, as I type 1500, you see both ordinates set, and I have a surface of 1500 by 1500 mm, which I'm going to pull, and I'm going to type 5000. It's a 5 meter by 1.5 sides of the square column, and I make it a group to keep it in a single entity. I can copy these, keep a multiple copy to explain it out to you. As you see, there are multiple ways of using the Fredo scale. If I select one of the entities, a component, and I click the box based transformation or the scaling, when I select and increase, it goes on for uniform scale with any edge or the scaling points that are. The next option, you can taper it with the box. Now how this tapering works is, you can taper any one surface. If you can click or as you hover around the black boxes, you can see the surface turns red, which tells you that the surface that you are selecting is going to be the one that you are going to scale or taper around. The moment I click and I try to bring it down or move it around, it takes me only in the direction up and down, because that is the ordinates that I am holding. If I hold it in this end, it is going to reduce gradually from the corner and go down, changing all the surfaces with the connected edges. So I'm going to click and see what happens. You can see the whole geometry is created. Similarly, I try that again and do it on the vertical or the horizontal edge. I'm going to pull. The moment I click, it splines or decreases the other surfaces as you want it in the box. This option is not exactly available in the Google SketchUp basic toolbar. Coming to the next option, let's see how this box planner works. If you see, you have the ordinates of scaling not exactly on the edges, but only in the center points of the surfaces. When you see and you try to explore, any point that you click in moves out of the geometry and changes the shape to the extent that you're moving it. I escape and I try to bring this geometry to the upper surface, I can easily move around and can make the column tapering without disturbing any angle between the horizontal or parallel surfaces. So if I'm going to click it, I'm going to make it a slanted one. Similarly, this is free plane shearing. That is, if I have to, on this surface, create a twisting effect, I can pick one of the points in either of the direction. You can see as I hover, it is automatically detecting the points and the axis as well. Colors of the rotating scale are changing. So if I click, you can see a line is activated, which is free without clicking any points or the cursors. I bring it along the surface that I want it to be. And the moment I click, you can see I have to choose the target point. And as you see, it keeps that one surface constant and in an angular or a radial manner, moves the whole plane and changes the DOM geometry. You can see the size has changed. You can definitely have a different shape of the column which you wanted. To the next option, let us click and select the next component. And you can see this is box stretching. Whatever pick point you pick gives you a dotted parameter of the plane that it is going to fiddle with. For example, if I click this box, you can see it is only going to increase or scale up in the green direction. That is the axis of green color. If I pick it from the other side, you can see it only increases on the red axis. Similarly, from the blue, it will only scale up in one direction, unidirection. So this usually comes up in use when you are making a building and you want the bottom surface to be fixed and the other surfaces or the columns to be editable and moving in the upper directions. This is one of the most interesting one that I'm going to use now. This is known as the Fredo box twisting. As you can see, you have these divisions visible as you hover above, and you can see how it divides it into the entities that can be turned. I'm going to click this surface and you can see there is a free roaming and rotating circular scale. I'm going to auto detect the middle point and stay around here. Click and try to rotate. You can see the bottom axis remains the same, whereas the shape can be turned and twisted into a very interesting geometry. And you can also type the angle, which you can already see in the green dialog box is written, and you can change the angle. I'm going to type 60. You can see the column has turned up to a 60-degree angle. You can create many beautiful designs, interesting geometries with this tool. The next one is feeder scale of box rotation. If I click and try to rotate with the box, and in the previous one, like we have used the rotation tool, we are going to rotate the whole scale of the box in the direction that we want. And this one works, you can say, more like the rotation tool. Now I can show you the very last of the tools in the Fredo 6 rotation tool. You can see I have a free detecting rotation circle on the surface that I am using, and the moment I click and I try to twist, I'll pick up a target point. It's going to be this, and then I'm going to rotate, and as you can see, I've rotated the whole entity to exactly the point I wanted. This is how I'm going to retake the surface, and I'm going to rotate that surface, and in the angle that I want, I can scale and change the only side that I want to. You can see, you can play around with many shapes, and you can make any number of designs that you want and create beautiful forms in architecture using the Fredo 6 Fredo scale tool.